Good afternoon, everyone. Today, we like to introduce the damn vulnerable DeFi. There are, a bunch of challenges over here. We are going to focus on the first challenge called Unstoppable. This is essentially a DeFi contract that allows people to do so-called flash loan. Means you can borrow a lot of token in one transaction, return it, and then within that transaction, you can use the flash loan to trade or to do arbitrage, buy something here, then sell there, and then gain. So this is one of the things that's very unique in the DeFi world. So we have two contracts we're going to talk about. Uh, so the goal of this challenge is make this flash loan contract stop. In other words, not functioning. So other people cannot uh, make flash loan from the contract anymore. All right. So basically, it consists of two major contracts. I'm going to explain both contracts over here, but I'm not going to talk about the solution. Okay, the solution is going to be an exercise, but I'm going to give you some hint. But before we talk about the unstoppable vault, we understand this is the contract called unstoppable vault. So it's a vault. So as you can see, it's inherit the super contract ERC 4626. So in other words, unstoppable vault is a special case of ERC 4626. So we need to understand what is ERC 4626 first. Turns out ERC 4626 is a special case of ERC 20. We already talked about ERC20 tokens, which have support the standard interfaces. So what is ERC 4626? In one word, it's a contract that allows people to store their tokens. Basically, we call assets. So the word asset means tokens that already very popular, tokens that already have a value, already in the market, maybe available in every DEX and centralized exchange and decentralized exchange. So when people put stock them over here, then they will in return they will get some tokens, and that we call shares. Okay, so it's like the whole pizza. So in this case, the hope is the vault is going to grow in asset. For example, maybe the value for a startup, and then the startup earn a lot of money, and then the money will be represented as some kind of token over here. For example, the stablecoin, USDT, USDC, or Ethereum, and then the, the the revenue of the company will all store in this vault. So you can imagine the pizza will become bigger and bigger. And then the token, which is the shares, is going to, proportionally share all the asset in the vault. So the bigger the vault is going to be, then the more uh, asset, let's say USDC, every share is going to get. Okay, so you see there are a few functions here which are very important. First of all, the constructor is going to uh, create a vault with the address of the asset. So in this case, let's say it's USDC, the stable coin. And then you can create a name and a symbol for this particular token. Okay, so you use the token to exchange for asset. Okay, and vice versa. So deposit basically is you put your USDC in this vault, and in return, let's say you get back a token. Let's say our token you can call Disney tokens. How about that? Okay, suppose this vault is for Disney. So you deposit USDC, you get back Disney tokens, which is the main over here. On the other hand, uh, so that this main is we can main the shares to the receiver. Okay, so the asset is going to be So this deposit meaning similar. Okay. The difference is here, the amount is in the USDC. So this is how much USDC you're going to deposit over here. So main is also similar to deposit, except over here, you are inputting how many shares do you want to get. Okay. So in the same way, in both cases in line 51, we are going to transfer the USDC from the caller MSG sender to the vault. Similarly over here. But we need to have some calculation. For the first one, we need to calculate how many shares we are going to get. For this one, is we already know the share, so we need to get how many USDC I need to deposit. In other words, this is the amount of assets. Okay, so this is the asset amount. So withdraw is the opposite. So this is how much USDC you want to withdraw, and then you calculate how many corresponding share we need to burn. Okay, so we burn the token, the destroy, the burn the Disney tokens. In return, you get back of the USDC asset. On the other hand, redeem is similar to withdraw, except over here is you input how many shares of Disney token you are going to burn, and then in return, you are going to get back the corresponding amount of USDC tokens asset. Okay, so basically this is how you do it. And over here you see kind of preview redeem. Basically, it's a conversion from shares of Disney shares to the USDC amount, and then preview withdraw. Similarly, it's from the other way around, from this to that, and a preview mint is from share to assets, and preview deposit from asset to shares. So these four functions, they are pretty similar, but they are slightly different. The difference is in terms of running up or running down. Okay, so some of them are running up, some of them are running down. So just slight difference. So that's very much for the ERC 4626. So over here, this one special function we need to notice. That's called total assets. Interestingly, the total assets is not necessarily all the assets uh, in the vault. And the reason is obvious because the whole company is not going to share all the assets with all the people. So maybe only 80% or maybe only 60% is going to be shared by everyone. The 40% might be, we call reserve. Okay, is going to be reserved inside, maybe for operating the contract, maybe for management fee and so on. So this is why the function total asset is not going to be implemented by the 4626 standard. It's going to be implemented. It's a virtual function. So it's going to be implemented by the particular implementation of 4626, which is abstract contract. So you need to implement a real contract over here. So if we go here, unstoppable vault, this particular vault, the first thing you need to implement, as we said, because all other function already implement, is the total asset. So in this example, the total asset happen to implement it as the total amount of asset in this vault, but that doesn't have to be. You can say 80%, right? You can say 60%, but in this case, they allow the whole amount of the balance of this asset in the contract to be allocated by all the shareholders. Okay, so this contract allows people to do flash loan. Let's do it from the beginning. So it's first of all, it's a special case 4626. Then the constructor basically allows to set the owner, which is the owner of the contract, and then a fee recipient, because flash loan they charge some interest, but in this case it could be free. Okay, so if there's interest, then this is the person who is going to receive the fee for flash loan. And then there's a restriction for each person how much loan you can make. And this is a max flash loan. It's one of the check they're going to do. And in this case, they don't give so much restriction. So they can actually, in one shot, borrow all the money in the total assets. In this case, 100% of the balance. So, and then this is a calculated flash fee. And then in this case, they double check if the token, if the token, which is argument, is the asset or not. So they don't allow this function to be called if it's not about this asset. And then they also check the period. If it's within this period, no fee. Otherwise, they calculate the fee over here with the formula. I think it's like 5%. And then they can change the CLCPN. Of course, only owner can make this change. And then we already explained this to the asset. So here's the meat of this contract. As you can see, the flash loan is a contract that everyone can call. You call it, then you can make a loan. Other people call it, other people can make a loan. But however, everything has to be done within one transaction. Okay. So first of all, you are going to specify who is going to receive the loan. Secondly, you need to specify which loan, which token you are loaning. Okay, and of course has to be this asset. They're actually doing the check. So 994, they check that the token actually has to be equal to the address of the asset. So there's really not a choice actually for the second one. The first one is a choice. The third one is amount how much you're going to loan. We know it's up to the limit of the total asset the max loan is. And then optionally, the caller can provide some data over here as a callback. Okay, we will explain that later. So this data is specified by the caller. So there are a few checks. Actually, one of the things that in smart contract is they have a lot of if. So if, well, if one time if fail, usually it's going to refer. That means the function is going to cancel. So the first one is okay. Don't bother to loan zero. Not interested. The second one means well, only borrow this particular asset. If it's not this particular asset, sorry, we don't offer you. And then usually we try to get the balance before, which is before people borrow how much, what is the balance? What is the balance? Because we need to check that when other people, uh, when this whole transaction done, our money will not decrease. It's going to increase, right? Plus, at least not decrease. Otherwise, people steal the money away. So flash loan means when the whole flash loan finish, you don't lose money. The file doesn't lose money. So they have this convert to shares function, which is converting the total supply, which is all the all the total supply, which is all the shares, and converted to shares. So this is a total supply, which is the total supply over here. So they are trying to check if the total asset is equal to balance before or not. So this is trying to check if the balance is correct. Okay, and then 97 is going to calculate flash fee, and then next one now 999 is the real deal. It's going to transfer the amount of asset, in this case token 0, which is equal to asset, to the receiver. Now by now the receiver received the money. Okay, then we are going to call the receivers on flash loan callback, which is the clients, if you can say, the borrower's contract with these 5 arguments. And then we are expecting the receiver is going to return this value. If it's not return this value, sorry, that means it's not a valid on-flash long callback function. And in addition, we expect this function is going to approve this particular contract unstoppable vault the right amount of allowance. Okay, so once we have that, once that's done, then 104 line will be successful. So 104 line is trying to transfer the amount of money from the uh, receiver to this vault, and the amount is the amount plus the flash fee. Uh, so in other words, uh, if 104, if line 104 is successful, then the flash loan will be successful. Otherwise, it's all or nothing, right? So at this point, 104 will get back all the money from the borrower. Okay, and then finally, it's going to send the fee back to the send the flash loan fee, the protocol fee to the fee recipient, and then return true. Okay, so if you want to solve this challenge, one of the things you want to check is you can think about how we can make one of the if statement always fail. If we can somehow make one of the if statement always fail, that means flash loan is stopped. Nobody can, loan anymore. Okay, so that's it. So let's see the other one. The other one is the contract that people use to receive the flash loan. So what do you do is you call this function. But let me explain from the beginning. So we deploy this receivable receiver unstoppable with the pool address. So the pool address is basically the unstoppable vault address, the previous contract we talked about. So that will be in the pool immutable. We're not going to change it, so it's unstoppable vault. And then we initiate this. We call the earlier flash stop. So we call that with the for argument. The first argument means this is where the loan is going to send. So which is this particular contract. Okay. So we're going to send. We are asking the flash loan to send back to myself, and then we specify the asset. In this case, the asset is going to be the pool's asset. So because I don't have a choice actually, right? Because they are going to reject it if I provide another address over here. Then this is the amount we are going to loan, and then I don't provide any callback data over here, so simply empty. In general, this could be more complicated. And then once let's call this is a function A. So function A call function B. So flash long is function B, and then flash long is going to call back function C, which is on flash long. So call back function C. So we're going to explain function C over here, which is on flash long. So on flash long is going to do what? It's going to check if the initiator, and of course that's A, is addressed this. So we know it's equal to this, so we are going to pass this, right? The initiator is is this argument, basically this one. Okay, the first argument. So we check that's the case. Okay. The second one is we're going to check the caller is uh, the vault, the unstoppable vault. Okay, we don't want other people to call this function, so it's as a protection. And then the third one is we want to make sure the token is the pool's asset, not the other token. And then number 4, because we want to make free, so the fee has to be 0. Okay, the fee has to be equal to 0. Otherwise, we revert. So this is a protection for myself. Okay, and then now because the caller, unstoppable vault, expect me to approve allowance, which is in this amount. Okay, and this amount, by the way, is not this amount in general. Okay, don't consider these two amount looks like similar because actually this amount is from the over here. So it's actually this line. So it's actually actually it's the same amount. So this is same amount over here, this amount. Okay, I'm sorry. So unstoppable receiver. Okay, I think I saw a bug already. So in general, the proof should be pool and then amount plus fee because the unstoppable vault is going to charge amount because exactly to approve amount as well as the fee. Okay, but in my case, the fee is always zero already, right? Because I use this line to check. If it's not zero, I'm not going to make a flash loan. So I don't have the amount plus fee. Okay, I think that's explained. And then eventually I have to return this magic number, which is 32 bytes key hash number, because otherwise the unstoppable fault is going to fail because they check the return value. So by now, the flash loan will be successful. So this C will return back to B, B will return back to A right here. And then uh, in this example, we borrow and we return, we do nothing. But you can imagine, uh, you can imagine that um, you can imagine that between line 28 and 31, in other words, I got money now, but between line 28 and 31, actually here, I can use this money somewhere else. For example, I can trade, I can buy something, return, I can buy from one place and then sell in another place. And then this is called arbitrage and earn some profit. And then we return. So in that case, we can use a loan between line 29 and 31. Okay, so that's how people use flash loan in real life. They borrow it and then return it between line 29 and 31. So thank you very much. Have a nice day.